بسم الله الرحمن الرحيم. Chapter 5: Classification and Balancing of Chemical Reactions. In this chapter we will show the chemical equations, balancing of chemical equations, precipitation, acid-base, or neutralization type of reactions. A chemical equation is an expression in which symbols and formulas are used to represent a chemical reaction. To the left of the arrow of the reaction, reactants, to the right, products, using the formula for reactants and products. All ingredients in a chemical equation and their relative amounts are given. The equation starting material and final products are listed in this equation with chemical names replaced with formulas. A reactant is a substance that undergoes change in chemical reaction and is written on the left side of the reaction arrow, while product is a substance that is formed in a chemical reaction and is written on the right side of the reaction arrow. Necessary conditions are written above the arrow, for example, heat or light or sometimes catalyst. These conditions should be written above the arrow, so the chemical equation shows reactants, products, and the conditions necessary. Chemical equations must be balanced. The number and kinds of atoms must be the same on both sides of the reaction arrow. This is the law of conservation of matter and charge. قانون حفظ المادة, the law of conservation of matter and charge. For example, in this equation should be balanced NaHCO3 multiplied by 2 to balance sodium and the carbon and the hydrogen and the oxygen. Also, equation should indicate the state of matter of these substances. S means solid, L liquid, J gas, aqueous, dissolved in aqueous solution, AQ. These substances that take part in chemical reactions may be solid, liquids, gases, or dissolved, aqueous. This information is added to an equation by placing symbols S for solid, L for liquid, J for gas, G for gas, aqueous for dissolved in aqueous solution. The equation should be balanced, so use certain coefficients, which is a number placed in front of a formula to balance chemical equation. For example, the coefficient 2 multiplied by substance NaHCO3 sodium hydrogen carbonate placed in front of NaHCO3 in order to balance the number of sodium, hydrogen, carbon, and oxygen atoms. Balancing a chemical equation in the process of balancing an unbalanced equation, first use the correct formulas for all reactants and products. For example, hydrogen and oxygen must be written as H2O2. These atoms found in the elemental state as H2O2 rather than as H and OH, H and O. Also, other examples of diatomic molecules like N2, Cl2, Br2, I2. There are 7 diatomic molecules beside the hydrogen and the oxygen. Subscripts in chemical formulas cannot be changed during the balance process. subscripts like O2, 2 in O2 or 2 in H2. These numbers are subscripts, cannot be changed because change in these numbers means change the identity of the substance. If you change O2 replaced by O3, O2 oxygen, O3 ozone, ozone and oxygens are two different substances. So you can change the coefficients, but you cannot change the subscripts. Second step in chemical balance, add appropriate coefficients to balance the numbers of atoms of each element. Begin with elements that appear in only one compound or formula. Leave elements that exist in elemental forms such as oxygen and hydrogen until last. For example, in this case, sodium is balanced first because it's found just in NaOH and Na2CO3. Na2CO3 contains 2 sodium atoms, so NaOH should be multiplied by 2 coefficient. Add this coefficient. If a polyatomic ion like SO3 appears on both sides of an equation, treat them as one unit. 1 unit SO3 here, 1 unit SO3 here. A sulfate ion on both sides, the same. If a polyatomic ion appears on both sides of an equation, it is treated as single unit. Now balance after balance SO3 and sodium. Now you can the complete balance of equation means balance hydrogen and balance oxygen by multiplying the water with 2 to have 4 hydrogens and 2 oxygens. Step 3, check the equation to make sure the numbers and kinds of atoms on both sides of the equation are the same. Step 4, make sure the coefficients are reduced to their lowest whole number values. For example, in this equation, 2H2SO4 plus 4 NaOH produce 2 Na2SO4 and 4 H2O. You can simplify these numbers by dividing the whole equation by 2. Now the ratio between these substances in the lowest whole number, 1 H2SO4 to 2 NaOH to produce 1 Na2SO4 and 2 water molecules. Natural gas methane burns in oxygen, yield water. This is the equation of combustion reaction, unbalanced equation. Now start first to balance carbon. CH4 contain 1 carbon, carbon dioxide CO2 contain 1 carbon, so carbon is balanced. Then balance the oxygen by and the hydrogen by multiplying the water with 2. Now you have 4 hydrogens in CH4. There are 4 hydrogens, 2 oxygen plus 2 oxygen in carbon dioxide. So O2 should be multiplied by coefficient 2 to balance the oxygen. Oxidation of butanol. This is the equation. Always oxidation or combustion reactions result in carbon dioxide and water, reduce carbon dioxide and water. In this equation, C4H9OH butanol with oxygen O2 plus O2 produce carbon dioxide and water, but the equation is unbalanced. Start balancing the carbon by multiplying the carbon dioxide by 4, first step. Then balance the hydrogen by multiplying the H2 here 10 by coefficient 5, multiply the water molecules by 5 to balance the hydrogen. Finally, balance the oxygen, count the number of oxygen on the left side and compare with the right side. Now 5 oxygen in water, and 4 multiplied by 2, 8, 5 and 8, 13. On the left, there are 3 oxygens. So oxygen should be multiplied by 6. 6 multiplied by 2, 12, and 1 from butanol, 13, to balance the 13 oxygen on the right. Now leave balancing oxygen last because it found in many formulas. Balance equation, finally, any atom of these atoms are balanced, and also the charge here 0, charge here 0, product 0, 0. Also beside matter is balanced, also the charge is balanced. To balance NaClO3, NaClO3 sodium chlorate decomposes in this way to produce sodium chloride and oxygen. To balance sodium multiplied by coefficient 2 for NaCl by 2. balance Na وbalance Cl. Now finally balance الأكسجين. In this case 3 multiplied by 2, 6 oxygen atoms. O2 should be multiplied by 3 to have 6 oxygens and balance all atoms like this. Balance chemical equation N2H plus H2 in gaseous state to produce ammonia and H3. This reaction called Haber process, and used to prepare ammonia. Start balance with the nitrogen, then balance the hydrogen. And ammonia should be multiplied by 2. Now the hydrogens on the product side, 2 multiplied by 3, 6 hydrogens. Here 2 should be multiplied by 3 to balance the hydrogen. Reactions type. First reaction type, precipitation reactions. These reactions are insoluble solids result in these reactions. Precipitation reaction are processes in which an insoluble solid called a precipitate forms when reactants are combined in an aqueous solution, like the experiment here. 2 solutions added to each other, insoluble salt, called precipitate result. Precipitation reaction will occur on mixing aqueous solution of 2 ionic compounds. Depends on the solubility of the product. If one of the product is insoluble, a precipitate formed. Solubility is the amount of compound that will dissolve in a given amount of solvent at a given temperature. If a substance has low solubility, then it's likely to precipitate from an aqueous solution. On the other hand, if a substance has a high solubility in water, then no precipitate will form. Precipitation occurs when one of the result is insoluble to form a precipitate. General rules on solubility. Compounds containing these ions group 1A or ammonium cation are soluble. Compound is probably soluble if it contains one of the following cations. Group 1 cations, lithium plus, sodium plus, potassium plus, and so on. Ammonium cation, NH4 plus. Any ionic compound containing these cations, it is probably to be soluble. For these cations. For anions, a compound is probably soluble if it contains one of the following anions, halides, except with silver, mercury 1, and lead. These ionic compounds containing Ag, Hg2 2 plus or Pp 2 plus form insoluble salts. Other anions, other cations form soluble salts with chloride, bromide, or iodide. In other words, all ionic compounds containing Cl minus, Br minus, I minus are soluble except AgCl or AgBr or AgI or Hg2Cl2, Hg2Br2, Hg2I2 or BbCl2, Br2, BbI2. These ionic compounds are insoluble. Nitrate containing compounds always soluble. Containing perchlorate always soluble. Containing acetate CH3CO2 minus. These anions, any ionic compound containing these ions are soluble. Sulfates, all ionic compounds containing sulfate are soluble except ionic compound with barium cation, Hg2 2 plus cation, Bb 2 plus cations. These ionic compounds are insoluble. Barium sulfate insoluble, Hg2 SO4 insoluble, Bb SO4 insoluble, BaSO4, Bb SO4, or Hg2 SO4 insoluble. Other ionic compounds containing sulfates are soluble. This table shows the solubility guidelines for ionic compounds. All ammonium compounds are soluble, no exception. All ionic compounds containing lithium, sodium, potassium, group 1A, all of them soluble, no exception. All ionic compound containing anion, nitrate, or chlorate, or acetate are soluble, no exception. Chlorides, bromide, iodides, all ionic compounds containing these ions are soluble except with silver, mercury 1, or lead. These compounds form, or these cations form, insoluble halides. Sulfates, again, sulfates, all ionic compounds containing sulfate are soluble except with barium sulfate, mercury 1 sulfate, and lead sulfate are insoluble ionic compound. Will a precipitation reaction occur when aqueous solution of cadmium chloride CdCl2 and ammonium sulfide NH4 2S are mixed? Yes, precipitation reaction will occur because the reaction is double displacement. The cation of this reactant react with the anion of this reactant. Double displacement reaction yields cadmium sulfide. Cadmium sulfide is insoluble, so insoluble ionic compound, while ammonium chloride is soluble aqueous, means there is no precipitate here. Only precipitate is cadmium sulfate. So the reaction is an example of precipitation reaction because the cadmium sulfide is insoluble. The state of matter S produce insoluble salt. So the reaction result in forming precipitate cadmium sulfide. Second type of reactions beside precipitation reaction Neutralization reactions or acid-base reactions are processes in which an acid reacts with a base to yield water plus ionic compound. In the general formula of acids, HA, الأسيد بروتون دونر H plus donor, البيس MOH الجنرال فورمولا. Now H plus donor donate from HA or accept from MOH base to produce water, and cation from the base and the anion from the acid form a salt. This reaction is called neutralization reaction. You neutralize H plus with OH minus to form neutral water. Any ionic compound produced in an acid-base reaction is called a salt, like the general formula Ma. The most common kind of neutralization reaction occur between an acid and metal hydroxide to yield water and salt. H plus with the OH minus form water. The anion is salt. The anion form acidic from the acid combines with the cation from the base to give a salt. For example, ammonia plus HCl NH3, NH3 plus HCl. HCl بروتون دونر بروتون دونر yes، والامونيا بروتون acceptor. السولت NH4 Cl NH4 Cl. Example, write an equation for the neutralization reaction of aqueous HBr and aqueous AOH. BOH contains 2 mole of OH minus, so HBr should be multiplied by 2 coefficient to form 2 hydrogen molecules. 2OH minus plus 2H plus form 2 water molecules. The Ba 2 plus needs 2 Br to form PaPr2. This is the balance equation of a reaction of HBr with the barium hydroxide. The third type of reaction after precipitation reaction, one neutralization reaction, oxidation reduction reactions, or called sometimes redox reactions. Oxidation reduction reactions are reactions in which electrons are transferred from one atom to another. Historically, the word oxidation referred to the combination of an element with oxygen. Reduction referred to the removal of oxygen from an oxide to yield the element. The change here, either gain oxygens or yield oxygen. Today, the words have taken on a much broader meaning. It means losing electrons, oxidation; gaining electrons, reduction. Reduction is the gain of one or more electrons. Oxidation is the loss of one or more electrons. While the old meaning of oxidation, combined with oxygen, oxidation, removal of oxygen is reduction. This is the A2 minus convert to A minus by losing one electron. So this direction is oxidation, while in the opposite direction, A minus gain one electron to convert to A2 minus. This is the reduction. Reactant A might be anything: neutral atom, monoatomic ion, or polyatomic ion, or a molecule. Any of them lose electrons is oxidized. Any of them gain electrons are reduced. Oxidation, lose electrons; reduction, gain electrons. The electron transfer in a redox reaction changes the number of electrons of reactant atoms, while in covalent compounds, bonds are rearranged and broken, so new bonds are formed by gaining or losing electrons. For example, copper reacts with silver, copper metal, CuS, react with silver ion, Ag plus, Cu converted to CO2 plus. So الأكسيديشن of الكبر metal 0 for copper ion plus 2 from 0 to plus 2. The process is losing 2 electrons. So oxidation. Cu oxidized by losing 2 electrons to convert from Cu metal to CO2 plus, while silver Ag plus converted to Ag zero charge, while Ag ion Ag plus positive multiplied by 2. This is happened or occurred by gaining 2 electrons, so Ag plus reduced, while copper oxidized, reduced by 2 electrons, oxidized by 2 electrons. Copper wire reacts with aqueous silver ion and becomes coated like this, coated with metallic silver, the product metallic silver. This is an example of a redox reaction in where copper is oxidized and the silver ions are reduced. The same thing, 2I minus react with 2PR2 aqueous. The result is iodine I2 aqueous plus 2Pr minus. To know either oxidation or reduction, we will follow the charges. 2I minus became 0 in I2, so it loses 2 electrons to convert 2 minus to 0, while Br2 with 0 charge because it is in the elemental state of diatomic molecules, always 0 charge. Now 2Pr minus for product means 2 minus. This is occurred by gaining 2 electrons. Br2 gain 2 electrons to form 2Br minus. This process is reduction, reduced by 2 electrons, while 2I minus lose 2 electrons, oxidized to form I2. Iodide is oxidized while bromine is reduced. Oxidized because each atom of I minus convert to 0. Each bromine is 0 charge and decrease the charge from 0 to -1. Oxidation and reduction always occur together. Oxidation needs reduction, reduction needs oxidation. When one substance loses an electron, is oxidized, another substance must gain that electron, be reduced. An iodide ion gives an electron to bromine, forming iodine and a bromide ion. The substance that gives up an electron and causes reduction called reducing agent. A reducing agent, I minus reduce Br2 to Br minus, I minus called reducing agent. The substance that gains electrons gain electrons, bromine gain electrons to convert to Br minus. Gain electrons means cause oxidation of I minus. It is oxidizing agent. So oxidized element or oxidized substance is a reducing agent. Reduced substance is oxidizing agent. And this is the classification. Reducing agent loses one or more electrons, causes reduction, undergoes oxidation, becomes more positive or less negative. To know which is the reducing agent follow the charge. If the charge becomes more positive or less negative, this substance is reducing agent. Reducing agent mean lose one or more electrons, cause reduction. May gain oxygen atoms, reduction in the old definition of oxidation means gain oxygen atoms. An oxidizing agent gains one or more electrons, cause oxidation to others, undergoes reduction, becomes more negative or less positive. The oxidizing agent becomes more negative or less positive, or sometimes in the old definition lose oxygen atoms. Alkali metals and alkaline earth metals, group 1A and group 2A, are the most powerful reducing agent. They have low ionization energy, lose electrons easily. They will react to the pure water. As ionization energy increases, reducing power decreases. Reactive nonmetals like halogens and oxygens are powerful oxidizing agent because they have the highest ionization energy and the most favorable electron affinity. A generalization about redox reaction. In reactions involving metals and nonmetals, always metals tend to lose electrons while the nonmetals tend to gain electrons. The number of electrons lost or gained can often be predicted based on the position of the element in the periodic table. For example, aluminum, an element of group 3A, tend to lose 3 electrons to form Al3 plus, while chlorine is an element of group 7A, tend to gain 1 electron to form Cl minus, and the formula of the product is AlCl3, Al plus 3, Cl minus. To be neutral, formula should be AlCl3. In reaction involving nonmetals, the more metallic element, either if they are in the same group, further down is the more metallic, and if they are in the same period, the element to the left is the more metallic. For example, S and the oxygen elements of group 6A, sulfur as below oxygen, so sulfur more metallic than oxygen and tend to lose. While carbon with the oxygen, if carbon react to the oxygen, carbon and oxygen in the same period, carbon to the left of oxygen, so carbon tend to lose electrons while oxygen tends to gain electrons. General statement here, a more metallic element either in the same group further down or the same period element to the left tend to lose electrons, while a less metallic element up in a group or to the right in period tends to gain electrons. Some examples about redox reactions. Corrosion is the deterioration of metal by oxidation, such as the rusting of iron in moist air, rusting soda. The reaction of rusting of iron, Fe with oxygen, result is iron 3 oxide, Fe2O3. Another example of redox reaction, combustion. Combustion is the burning of a fuel by rapid oxidation with oxygen. The fuel could be gasoline, fuel oil, natural gas, wood, or paper. The combustion product always carbon dioxide and water. Some metals also will burn in air, like magnesium and calcium. The product is the metal oxides, magnesium oxide or calcium oxide. Respiration is an example of redox reaction. Respiration is the process of breathing. Inhale oxygen. Using oxygen for many biological redox reactions that provide the energy of the living organisms need. For example, energy is released from glucose oxidation with oxygen. The product carbon dioxide and water, and energy released. The energy released from food molecules slowly and in complex multi-step pathways, but the overall result is similar to that of combustion reaction. Metallurgy, the science of extracting and purifying metals from their ores. The production of iron from mineral hematite is an example of extracting iron. The production of iron from hematite. Hematite composed of Fe2O3 can be reduced. Fe2O3 using reducing agent, carbon monoxide, CO. Carbon monoxide is the reducing agent. Reduce iron 3 oxide to produce iron metal. Bleaching. Bleaching makes use of redox reaction to decolorize or lighten colored materials. For example, dark hair is bleached to turn it blonde. The oxidizing agent used here is hydrogen peroxide, H2O2. Clothes are bleached to remove stains. The oxidizing, in this case, sodium hypochlorite, NaOCl, sometimes commercially called Hypex. Wood is bleached to make white paper. The oxidizing agent used is elemental chlorine, Cl2. The example of bleaching clothes, colored dirt or dye with bleach and NaOCl in water, convert colored dirt to colorless dirt and Cl- and NaOH. Example, for the following reaction indicate which atom is oxidized and which is reduced. Copper with platinum 2 plus produce copper 2 plus and platinum metal. The copper change the charge from 0 to +2, increase the positive charge mean oxidation, so Cu is oxidized to convert from a metal elemental form to cation +2 copper oxidation, while platinum 2 plus converted to platinum +2 converted to 0 charge on platinum metal. The process is gaining electrons, reduced platinum 2 plus reduced to platinum metal, so copper is oxidized and acts as the reducing agent, while platinum 2 plus is reduced and acts as the oxidizing agent. In the second part, 2 magnesium with carbon dioxide result 2 MgO and copper solid. Magnesium 0 charge in the metallic state, in the elemental state. In the oxide, the Mg is +2. Mg convert from 0 to +2 by gaining, by losing 2 electrons. The carbon dioxide is reduced to carbon by losing oxygen. Losing oxygens, the magnesium is oxidized and act as the reducing agent, while carbon is being reduced and acts as the oxidizing agent. Oxidations either increase the positive charge or decrease a negative charge or lose oxygen. Again, oxidation lose oxygen reduction. For the following reaction, identify the atoms being oxidized. 2 aluminum, 0 charge, convert to 2 aluminum chloride plus a 3 charge. Aluminum increase charge from 0 to +3 by losing 3 electrons, so aluminum is oxidized. Carbon with chlorine converted to CCl4, C in solid state 0 charge, while in CCl4 +4. The charge of carbon increase from 0 to +4, so the carbon is oxidized. Classify the following as precipitation or neutralization or redox reaction. CaOH by 2 with 2 HBr, it is acid-base reaction, neutralization reaction. BbClO4 by 2 with NaCl form insoluble salt, lead chloride, BbCl2. So it is an example of precipitation reaction. Precipitate is lead chloride, BbCl2, lead chloride, precipitate. 2AgNO3 with copper, Ag plus converted to Ag metal, so it is reduced. Copper converted from 0 charge to copper nitrate, copper nitrate +2 from 0 to +2. This is reduction, so the reaction is reduction oxidation reaction. Oxidation number. Oxidation number, a number that indicates whether an atom is neutral, electron rich, or electron poor. How can you tell when a redox reaction is taking place? When ions are involved, determine whether there is a change in charges. If there is a change in charges, so the reaction either oxidized or reduced. If positive charge increase, it is oxidation. If became more positive or less negative, oxidation. On the other hand, reduction, positive charge decrease or negative charge increase. For reaction involving metals and non-metals, predict gain or loss of electrons. Molecular substances can be analyzed in terms of loss and gain of oxygen. Lose oxygens, reduction and gain oxygen oxidation. By comparing the oxidation number of an atom before and after a reaction, we can tell whether the atom has gained or lost charges in electrons. Rules for assigning oxidation numbers. An atom in its elemental state has an oxidation number of 0, like hydrogen H2, oxidation number 0. O2, oxygen, oxidation number is 0. Sodium, metal, oxidation number 0. These elements are in elemental state. An atom in its elemental state always has an oxidation number of 0. A monoatomic ion has an oxidation number equal to its charge. For example, an A+, oxidation number +1, oxidation number of calcium 2+, +2, and so on. For monoatomic ions, the oxidation number is the charge of the ion. Rules for assigning numbers in a molecular compounds. An atom usually has the same oxidation number it would have if it were monoatomic. For example, hydrogen usually form +1 cation with non-metals. Like in water, H2O, hydrogen is +1, oxidation number. Hydrogen with metals, especially group 1A to 3A, sodium, magnesium, aluminum, always the hydrogen is -1 charge. And with the transition metals, hydrogen is usually -1, the oxidation number with metals, group 1A to 3A and transition metals, while F always -1, F from halogens from group 7A. The common ion for fluorine is -1. Oxygen is usually -2, except oxygen, an element of group 6A, usually form common ion -2, except in OF2. In this case, with the F more electronegative than the oxygen, so the oxygen lose electrons or lose 2 electrons, form oxidation number +2 in OF2 with the fluorine. Peroxides, like the hydrogen peroxide H2O2, O2 form 2-, each atom -1, O2 -2. Superoxides, O2 charge -1 means each oxygen atom half oxidation number. So oxygen in superoxides, oxygen is half minus half. In peroxides, -1. In OF2 +2. These exceptions, oxygen usually form -2 common ions, oxidation number. In HCl with Cl non-metal, hydrogen form +1 cation. In water, hydrogen in HCl, hydrogen form positive 1 cation. In water, the same thing. Hydrogen with non-metals always form +1 cation. With the oxygen, with the nitrogen, with the chlorine, always the hydrogen is +1. For compounds with more than one non-metal element, the more electronegative element has a negative oxidation number, and the less electronegative element has a positive oxidation number. Like S والoxygen, S and oxygen are elements of group 6A. S more metallic, so form positive cation, and oxygen the more electronegative form anion negative -2 anion, will S +4 because it combined with 2 oxygens. And oxygen is the more electronegative than N, so it form a negative charge, while nitrogen is less electronegative, has a positive oxidation number, +2 -2 in NO. The same thing in for carbon and the oxygen in carbon dioxide. Carbon is less electronegative than the oxygen. The same period, carbon to the left, so carbon tend to lose electrons, while oxygen tends to gain electrons. General statement, the less electronegative always form positive oxidation number, while the more electronegative element form negative oxidation number. The sum of oxidation numbers, the sum of the oxidation numbers in a neutral compound is 0. The net charge in HNO3 net charge is 0, so plus cations should neutralize minus anion. Total +1 from this hydrogen, +5 from nitrogen, neutralized with 3 oxygen, 3 multiplied by -2, -6 +6, net is 0. So the general statement, the sum of the oxidation numbers in a neutral compound is 0. Example, what is the oxidation in titanium chloride? The oxidation state of oxidation number of titanium is +4. Cl is -1, 4 ions, 4 minus, so titanium should be +4, and the name titanium, Roman numeral for chloride, titanium for chloride. In this reaction, which reactant has been oxidized and which has been reduced? Iron oxide, iron 3 oxide converted to metal 0 +3 to 0. This is a reduction, so Fe2O3 reduced, while carbon gain oxygen means oxidized. Iron reduced and the carbon oxidized. Iron reduced, so it is the oxidizing agent. Carbon is oxidized, so it is the reducing agent. Ionic equation. an equation in which ions are explicitly shown, clearly shown in reactions involving ions, it is more accurate to write the reaction as ionic equation. Some ions do not change during the reaction, appear on both reaction sides, but play no role. They are called spectator ions, أيونات متفرجة. They are spectator ions, can be cancelled. The actual reaction can be described simply by writing a net ionic equation after cancelling the spectator ions, which includes only the ions that undergo change and doesn't include the spectator ions. A net ionic equation must be balanced both for atoms and for charge, with all coefficients reduced to their lowest whole number. All insoluble and molecular compounds are represented by their full formulas. For example, these general statements, the application for neutralization reaction, KOH with the HNO3 produce water and KNO3 salt, can be written in ionic equation. KOH in aqueous means you can ionize KOH as K plus OH minus. HNO3 ionized to H plus and O3 minus, like this, KOH, K plus aqueous, OH minus aqueous. HNO3 ionized to H plus and NO3. H2O in liquid state doesn't ionize. K and NO3 soluble in water, K plus aqueous, NO3 aqueous. Now spectator ions K plus appear to the left, appear to the right, can be cancelled. OH, NO3 spectator ion can be cancelled. So a net ionic equation is the reaction of OH minus with H plus to produce water. Net ionic equation after cancelling the spectator ions K plus and NO3 minus yields OH aqueous plus H plus aqueous produce H2O liquid. This equation called ionic equation without the spectator ions. Apply the redox reaction also. Copper in solid state with 2 AgNO3 produce 2 Ag in solid state plus calcium nitrate in aqueous. Now ionize CuNO3, can be ionized to calcium 2 plus and 2NO3 minus. Ag can be ionized to Ag plus and NO3 minus. Ionic equation, الكبر in solid state Ag plus aqueous, NO3 aqueous, Ag solid. الكبر nitrate can be ionized to copper 2 plus and 2NO3. 2NO3 spectator ions can be cancelled. Spectator ion in this case, NO3. The net ionic equation is copper solid plus 2 Ag plus produce 2 Ag solid and CO2 plus aqueous. After cancelling or elimination the spectator ions, the net ionic equation written. The net ionic equation confirms that copper is oxidized and silver is reduced. Copper change the oxidation number from 0 to 2 plus, increase the positive charge mean oxidation, while plus Ag plus convert to Ag0 plus to 0, decreasing of the positive charge means reduction. Cu oxidized while Ag plus is reduced. Write balance net ionic equation for the following: AgNO3 plus Z and Cl2 double displacement, Ag with the Cl form AgCl solid, Zn with the nitrate form Zn NO3 by 2 aqueous, so can be ionized. Spectator ion Zn can be cancelled in both cases. Zn with the chloride Cl minus, and with the nitrate net ionic equation is Ag plus aqueous plus Cl minus aqueous produce insoluble silver chloride AgCl in solid state. HCl with the calcium hydroxide لو H with the H plus the only ions reacted to form water, while calcium and the chloride are spectator ions, can be cancelled. Net ionic equation 2H plus 2OH minus produce two water molecules in liquid state. 6HCl with Al solid produce AlCl3 and hydrogen in gaseous state. Reaction Cl can be cancelled. 6Cl with 2 multiplied by 3, 6Cl appear on the both sides, can be cancelled, and the rest is the ionic equation. 6H plus with 2 aluminum in the solid state produce 2 aluminum, 3 plus aqueous, and 3 hydrogen in the gaseous state. The net ionic equation is balanced from number of atoms and charge also balanced. For example, 6 plus 3 plus multiplied by 2 plus 6 on the reactant side and plus 6 on the product side. This is 0 charge, this is 0 charge, so the equation is balanced from matter side and from charge side. Also for Ag plus Cl minus, net charge is 0 on the reactant side and 0 on the product side. The same thing, H plus 2 plus 2 minus, net 0 charge on the reactant side and 0 charge on the product side.